My name is Cassiano Aquino. I work at Zendesk. I'm a senior operations staff engineer. When they told me that, I was a little bit confused at what a staff engineer is, but it feels like this is just like, in practice, it's a tech lead. But they just put a different name. This way recruiters will not find you on LinkedIn. It's a way to evade search terms on LinkedIn. It's the best guess that I have. So I was like, I always start telling the two most important cities in my life are São Paulo in Brazil and Dublin. And why? I was born in Brazil. I lived there for my whole life, and I moved 3 years ago to Dublin. Actually, I was imported by Zendesk to Dublin 3 years ago. And I don't think we have any Brazilians around here. I think I'm the only one. So yeah, but it was a huge life improvement, especially that I don't have my mom asking to fix the alarm clock or the microwave oven, because they think that because you know computers, you fix all of these home appliances, and they tell that for friends and everything. I've been using NGINX for more than 10 years. I started using this for personal projects. Basically, I had one website that was busy for the time. I had like 15,000 users, and it was running a Pentium 4 with 2 gigabytes of memory, and like the one that should not be named was killing my server. Everyone knows who I'm talking about. Like 10 years ago, you didn't have a lot of web servers. And I said, okay, we have this new web server. It's not working, so let's try. And it was like love at first sight. I put in the server, all my problems were solved. It was working, and I said like, man, this is awesome. I want to use this everywhere. And what happened is that I have, like, how I end up in Zendesk. I have my blog, cshero.org, and I've been writing content for 5 or 6 years. And what happened is that I got lucky, and a week I got 2 of my blog posts they went for the front page of Hacker News. Then, like, one of the tech leaders at Zendesk at the time saw that and called me and said, hey, do you want to work at Zendesk? I said, well, yes, I would love to. And how I basically, NGINX not only solved my problem with my personal website, but helped me moving to another country, to get a job in a good company. So it was a real life-changing experience. So I will ask someone, who knows Zendesk here? A lot of people. Who uses Zendesk? So this is one thing that we have, because we have so many of our own vendors that use Zendesk, like Datadog, for example, and all these guys, that we are always concerned of the chicken and egg problem, because what happens if my production breaks and I need to open a ticket to them, but they use us? So we'll create a singularity and the whole internet will collapse with us. So Zendesk, I'll talk a little bit for the people that doesn't know Zendesk. Zendesk, our headquarters is located in San Francisco. We just passed over 1,600 people working at the company. And we have like 13 global offices spread all around the world. And when I joined Zendesk, it was pre-IPO. So like it was way smaller than what it is now. It grew like really, really fast. And even with all these changes and how it grew, I still love it, Zendesk, and no recruiter asked me to tell that or anything. So it's Zendesk and NGINX, I think, is like, other than my family, is the 2 biggest loves I have in my life. So, and Zendesk, it has a mission, because every relationship, you have like 2 sides for every relationship. And the business software was never created to do that. It was like you had your marketing software. It was created for like departments within companies, and not to relationship between a company and a customer. So this is what drove us in creating Zendesk and trying to create a better experience to have to support your customers. So and like the customers also, they expect like a single experience today. No matter if they are talking to marketing, sales, they would like to have like this unique experience that you don't need to have like different ticket systems and different other things to talk to them. So this is like, it was built to make like companies have better relationships with their customers. And we were lucky because we had a huge like user base, like Twilio, Box, Slack, a lot of big companies, and they helped us also to shape that, to understand what were their needs, what they needed, how they wanted to have a relationship with their customers. And because of that, Zendesk, like so far it was a single product, but then we split in multiple products. So Zendesk today we have like the old Zendesk ticketing system that we call support. And I'm explaining that because I will talk a little bit about like technical solutions for that we did for some of these products. So we have chat, guide. So we created that exactly to align to the customer's expectations and also for our own customers. So to talk about Zendesk, like I will start first with, let's talk a little bit about numbers, like what we have currently at Zendesk. We have an average of 25,000 requests per second, and this is not much, but I will explain why. I'm not like putting a number here just to look good, and I'm doing a full average across peak hours and outside of peak hours, weekends and everything. Because why I do that? Because I went to a lot of presentations that I see these companies with such big numbers, and I was looking like, man, this is not possible. How they get this such a big number? But then you discover, oh, they grabbed the biggest, like the peak of their time and did an average across the time. So it's easy to have big numbers. And I want to show the reality. It's obviously we need to plan for the picks, but I want to show that it's if I get my pick, this go like 5 times. We go through almost 150,000 requests per second. This is what, like almost 1.5 million requests in 1 minute in the whole infrastructure. Because we have 95,000 customers, but those are our direct customers. So like those are my customers using Zendesk. So I will cover pretty much 3 topics in the presentation. That is the past of Zendesk, the infrastructure, all these products, the present, what we are doing now, and what we expect for the future. All right, so about the past. I would like to talk a little bit more on how Zendesk used the NGINX open source. So Zendesk has been using NGINX since inception. Since day 0, we use it in NGINX. And like even our founders, like they were really supportive in moving to Plus and everything because it's part of our core. So every single request that you go to Zendesk, it will probably pass in more than one NGINX instance because we have our external proxy layers, and then each one of the host groups we also run NGINX, and then like at least you pass in 2 NGINXs for any request. So without NGINX, like Zendesk will not work at all. And also like another thing that we've been using a long time, we still use it in NGINX Lua. But what is nice, we started to use NGINX, the Lua model because, for example, with this adoption for microservices to all of these things, you have like simple things that are really important. For example, how you track a request beginning to end. Like how I know that that request that came in my proxy, called this server, then went to another API, how I can relate all of that. So we started using Lua to add these request IDs for every single request and then just have these added across all the ecosystem, every path in the way. But now in NGINX, we don't need anymore because NGINX has a variable, built-in variable called request ID that you can use that. And we are replacing because we are always up to simplify things if possible. And we also use Lua for some authentication functionality and everything. So to talk about like, because we've been using NGINX since the beginning, so automation around NGINX, it was a little bit of a challenge for us because every application that requires NGINX, it has their own, we use Chef to do like our automation. So it has their own cookbook, and then you need to go and do the change for that application also on the NGINX cookbook. So pretty much for every production change, you needed to do 2 changes. And this ended up with a cookbook that was over 9,000. Yeah, this sounds familiar. I'm not sure why over 9,000, but whatever. they have this. We had over 9,000 lines of coding in automation, which is completely unacceptable. And this was like, the people talk a lot of technical debt about like refactoring microservices, but if you use automation for a long time, the same happened with your automation. You need to review, you need to refactor, you need to do work and remove all the things, because over time it ended up like being a huge system to be maintained by itself. So, and why this was a problem? First, it was really hard to understand what is happening. And this is also a blocker for any team wanting to roll out any service, because they need to go change their own cookbook, then go and change the NGINX cookbook, and then another team is also changing the NGINX cookbook, and this causes a lot of trouble. I was even joking that the plural of DevOps is merge conflict, because it's everyone trying to commit things on the same repository and failing miserably. So, and then we need a solution for that, and I get back to there and like understand what and explain what we did to be able to improve that. And across all this time that we use NGINX, we learned some lessons that I would like to share with all of you. So, for example, reloads. Reloads, they usually don't cause any trouble. It works really well, but this is not true when you have almost 12,000 certificates. Like every time you reload, you have CPU spikes, you drop requests from customers. And then you start to learn how the internals of how it works. For example, all the SSL contexts, they are created on the master process and not on the workers. So what happens then, when you do a reload for a brief period of the time, the master will allocate twice the amount of file descriptors, and your master process will run out of file descriptors. And then you say, like, you see the message on error log, oh, not enough descriptors. You say, okay, you raise on worker R limit no file, but it's not the right place because it's the master process and not a worker that is running out of file descriptors. But this is really specific to to our infrastructure. Like, it's managing all these SSL certificates is a challenge, not only technically, but also security is an issue. How you keep all these keys secure from your customers. So it's a huge challenge. Also, things like, for example, before using NGINX Plus, we used the open source version, and we used the Ubuntu package. We just rebuilt it with the Lua patch applied, and we built using the Lua JIT, the default package from Ubuntu. And what happens that you discover that some of the compilation flags used for that package on Ubuntu itself, it set some flags that only let you allocate 2 gigabytes of memory. And when you have like 12,000 certificates, then it will fail. You'll not even start at all anymore. And then you need to go back to strace and try to understand what is happening, because it's really sort of cryptic thing. And because of the amount of certificates, the size, usually you don't find much help on the internet or anywhere, because you are pretty much adventure, like you are going in a place where no one has been before. So you need to try to use smart ways on how to find that. So then we had these issues, like we solved most of them, but we had our migration to NGINX Plus. That is one thing that it's always concerning, because this is a really crucial and important piece of software for our infrastructure. So how it will be changing that? It's like the people saying, okay, let's replace our Cisco switches by something else. And they say, oh, wait a minute, we need to do a lot of work. But what we discovered, it is like NGINX Plus is really a drop-in replacement for the open source version. It was a completely painless migration. It was like we just dropped the new package and it was working. To say that was not working, we had problems, but it was our fault. It was not NGINX fault. Because when we did the upgrade, it was not just like the move to NGINX Plus, but it was an NGINX version upgrade together. And what we discovered is that we had a bug that was fixed in these versions in the open source that Zendesk relied in a bug as a feature to work. So so the piece of advice that I have, if you want to migrate to Plus, first, go and upgrade your open source version, or at least grab the same release, the open source that is the same as the Plus, do the upgrade, and then you move to Plus. It's not that you'll not be able to troubleshoot to understand. It's just that will save your time wondering what can be the problem. Like it's the migration. It's that rule of don't do two changes at the same time. So, but while you're doing that, sometimes we forget about that because it's so like easy and so painless that we just replace it. So it's good to keep this in mind. So the problem we had that we relied the bug as a feature is that we relied in XSL redirect to like serve big files and all of these things. And what was happening is that according to RFC is not how it should be. Is that when you do an XSL redirect, he was preserving the method that came from the client. So if it was a post, it was gonna be a post for the backend. If it was a put, patch, delete, whatever it is, it was going to like just preserve that. But this is not, if you go and read the RFC, it's not how it should be. This, like, it always should be changed to a GET request. So when they fixed that, we start to fail because like we start to use it, was working, no one bothered in going looking at RFC, understanding how it worked. So it was our fault, and not at all NGINX. And thanks to the NGINX changelog that it has everything that was changed in every release, we were able to identify really quickly what was the problem. And just by looking, because like this, one thing that I also like is that feels daunting and like really hard to understand NGINX, the source code, but when you have the changelog and you compare versions, you see that it's not that much code that you have every release. They add a lot of code, but it's really easy to pinpoint, okay, what is related to this XSL change, and you can see like, then what we figure out is like, okay, so we can still use named locations internally and will work the same way. So like it's the source code is really useful. Even if you don't use you use Plus, you can still rely on the open source source code to be able, as a documentation for you to troubleshoot and understand how things working. So how we solve it? Like for example, this is a workaround. It's not a root cause thing that we can solve. So the SSL reload issues. Basically, the final solution for this would be to have like lazy SL context creation that we are discussing and working together with NGINX to have this. But we know that this is really specific to our use case. This is not something that the broader audience needs it. So like again, it's something that sadly we need to. So what we did was we added like, because we have this automation process that generate all the certificates, put in place for the customers, and especially after Let's Encrypt got more mainstream, we saw a bump in the amount of SSL requests going to our infrastructure. So what we did was to spread the reload of our proxy nodes in different times. So basically what we do is, oh, I need to go and do a reload. So are you doing a random interval of like 5 minutes? This way I guarantee that I don't have all my proxies reloading at the same time. Because we still have the problem. Like some connections use slow down, but it's not the whole platform having the issue. It's something specific. This way you have time for your load balancing, do service check and react, take the node out from the pool and do what needs to be done. So this was the way to solve that. And for the XSL redirect, as I told before, just by using named locations pretty much solved the problem. So this was like what happened to us on the past. So let's talk a little bit more about the present of Zendesk after NGINX migration. So Zendesk now we have like our own data centers, but we are also in Google Cloud Engine, we are in AWS. So one of the biggest challenges we have is exactly load balancing. It's not that these platforms, they don't have load balancing. They all do. But then when you need to like do a training with your team, you need to train 15 different technologies on how to do the same thing. And the problem is like it has cost, especially when you have any incident. Like if you had a red alert that your company is down, that you go and say, oh, it's a load balance, let me troubleshoot. And after 15 minutes, you discover that, oh, it's not this load balance, it's the other one. So simplifying this, like not only the architecture, but the amount of knowledge needed by the team to be able to troubleshoot, to operate this platform, it has a huge value to instant response, to capacity planning, for a lot of other things. Because, for example, capacity planning. Let's play a completely crazy thing now. Imagine I'm in the middle of the night and they say, okay, we are running out of capacity on my load balancer layer. So within NGINX, if I'm going completely crazy, I can just go grab all the computers in the company, install Linux, put in NGINX, drop it there, and tomorrow I will buy proper servers. But I want to see someone doing this with an appliance load balancing, because this will take months to receive any new equipment. You need to go buy, wait to be delivered, RMA, all of these things. So like having this freedom to be able to change so fast is a thing that gives you a lot of power to be able to grow your company, to give power to your team, like we work at Zendesk, to give power to us to create the proper solutions without being blocked by external vendors. Another thing is, it's like most of the load balancers applies, they have APIs, but when you go to look at the documentation, it's probably written in Perl or something similar that feels like it was written in 2001. And they don't give the same attention that NGINX does for this kind of detail, to have a modern set of API requests, API endpoints for you to be able to work, integration with service discovery, all of these things, because it's impossible for any enterprise, any company to keep the trends that we have now developing, like microservices and everything that is needed, without having this sort of technology. Yes, you can do. You can, I'm not gonna lie, you can grab your appliance and do, but you invest a lot of money to create a workaround to do what NGINX does for you out of the box. And that then you can focus on your business, like what is the core business of your company, and get more money to the company instead of creating a lot of automation scripts for one specific box that you have. So in the process, like getting back to automation, so what we did to avoid having this, one thing that I would like to start is, there is no better or worse on this. It's pretty much pick your poison. Like what we did here, instead of having during deploy, when you build the change, you have this dependency across cookbooks, and we transformed this into a runtime dependency. That this NGINX cookbook has port functions, and then any other cookbook you can leverage these functions and create NGINX configuration. So pretty much like how it works. Imagine that I want to create a cookbook for Zendesk Talk. The only change you need to do to have NGINX deployed, like the configuration for your proxy node, the configuration for the nodes where the talk runs, you call a function that is from the NGINX cookbook, and then you say like what port, what is the location that needs to be mapped on NGINX, what is the parameters of configuration. This way, when you need to do any change, now each application, they are responsible by their own configuration, their own NGINX. They don't need to go and touch another cookbook. This is done externally to the other cookbook. And it works like, it's better than having 9,000 lines of automation in a single place. This is like, we don't have any questions about that. So service discovery, that is something that we rely a lot, and for the future we will be relying even more. So in my opinion, like feels like that service discovery is like a new sort of a dial tone service. What I mean by that, for me it goes in the same category like DNS, DHCP. It's like for a modern architecture, you can't do it properly without having some sort of service discovery. Even if you abuse other things, like, oh, I add DNS records through API and then I can resolve the DNS, or you use Amazon API to query the servers. So it's still service discovery. It's just that you are not using a proper solution for it and you are building your own. But because imagine, service discovery is not just to solve problems for, like, microservices feels like it's a huge barrier of entrance if you don't have proper microservices in place. because how you coordinate all of that, and more than anything else, like how your operations knows what is running where and talk to without service discovery, because the environments are turning something way more like, organic is not the right word for that, because there is nothing organic, but the way that applications shape each other, they talk to each other, feels like it. Because people is adding new applications. They are like, we are moving to this platform as a service to be able to do like self-service for applications. So this is changing like a living organism and growing all the time. And when you see it's like after 2 weeks, you look and say, man, but we have 10 more applications running in production that you don't even realize anymore. And this is a big challenge, especially because Zendesk is working really hard to have like a full platform as a service adoption within Zendesk. So this is like for us is really crucial, and that's why it's on the same category as DNS and other for us. And one of the really nice things is that integration with NGINX Plus with any service discovery that exposes a DNS interface is really easy. In our case, we use Consul to do that. So as you can see, like pretty much if you need to use service discovery, it's as easy as, it's pretty much, this is the only thing you need for NGINX. You tell like, I want you to query my console for the service, my application, and I want you to resolve that. And you have a list of upstreams that this will, like if containers spin up, go down, anything happens, like they fail or people deploy new applications, this will be always up to date with no configuration changes, with no human like interaction or anything. It will just work. And this is what we need for microservices and for everything. So any of you use also Consul? I'm not talking to you. Well, like it's, Consul, like we chose it because it's a really simple like approach on how to do service discovery. Is pretty much you drop a binary, you start it, and you have your service discovery working. And you get some details on how we use it and some nice features and how we integrate that with NGINX. So what you can do with Consul and NGINX together. So you have like this, the basic DNS interface that you can say like, okay, I want one tag .service.console, like it can be the name of my application or master dot the name of the application, because these tags are arbitrary. You can put any tags you want to your service. And then this DNS record is used like a filter to the result set that you receive with the nodes that should go to that upstream. But Consul has another nice thing that is called prepared queries. So this is a little bit confusing for the people that know SQL because it feels similar. And somehow it is. So pretty much what you can do with that is you can create a configuration that you say, okay, every time that someone queries application dash production or pre-production dash anything .query.consul, I want you to go on Consul query the service name application. This can be up to 3 data centers away from me based on response time. And this is near to the agent because we run Consul in every single node. I want only the nodes that are up. And then what I will use this, for example, the production or pre-production to match with env dash, the tag name here, or for protocol, for example, we are starting to use gRPC. And we have like, okay, how we test that? How I can have part of my applications with gRPC and part we using REST. So it's pretty much for us is if you want to use gRPC, you put like application dash production dash grpc.query.console, and this will filter out based on tags to find which nodes are running with gRPC or REST in this case. So this way, like we have a way to filter this organism that is growing and changing based on prepared queries. And one thing that is really nice working together with NGINX is exactly this part of the failover, the nearest here. So how this works. Imagine that you have your service running that is pretty normal. You have like your local data center and then remote data center with the same thing running in 2 different places. But what happens that? Let's imagine, because like I heard a theory once that every single server, during a year, at least you fail once. No matter if it's memory, CPU that is completely used, like the failure is not just like completely dying. Can be any incident with that server. But when you have like 7,000 nodes like we do, things are failing all the time. But the secret is not making things not fail, because they will. Is how you don't make any failure an incident to your customer. It doesn't need to break your customer when something happens. So using the prepared query, you remember that what we had before was like, okay, I want you to tell me for the nearest 3 data centers, the one that is closest to me. So what happens, like, if this node, for example, goes down, what will happen at console, the DNS entry, you start to point you to the other node. Automatically, you don't need to do anything. Console takes care of everything for you. He'll just, like, the next time that the application resolves the DNS, it will go to the new backend, and you don't need to do anything. Why this works? Because console, as being a service discovery, you have also service checks together. Because, like, he needs to know what services are healthy or not to point your application towards that. And because of that, you can leverage these results of the health checks to route your traffic based on how healthy your backends are. So let's talk a little bit about talk. That is a little different use case from what we had. So our voice provider is Twilio, is another software as a service company. But the special thing that we have is that we have per request SLA requirements. So if we don't answer like the completely flow of requests in 10 seconds, it's a call that is dropped from a customer. That can be a sales call, can be someone with a problem. And this can, like, if you are with a problem, can be the difference between you staying with this company or you moving to another company because you were not able to talk. So it's, for us, it's really important to get all these calls through. So we have a completely isolated and dedicated cluster of NGINX just for talk. And exactly because we don't want to have all that SSL certificates there. We don't need. So we isolated, like we have a proxy layer just for this specific application. So, and what we do is we leverage, for example, service discovery, because service discovery has health checks. Then we also use NGINX health checks to check what is happening. But we also use the upstream max errors and everything. So we have effectively 3 different error checking for these backends. So if a request fails before any of the checks happened, the upstream max errors, you'll find this out. And but this still be a problem. Like imagine that the backend returned 500. So I don't want this to go to Twilio, or I don't want to go to my customer, because it's a call that can be dropped. So this is when the proxy next upstream comes into place. So you can instruct NGINX and say, hey, if my backend returns, for example, a 500, a 502, a 503, I want you to grab this request before answering, try another backend, and if it works, then you send this to the customer. So with that, we still see the logs with the errors. We can go and troubleshoot and do the work we need to do, but our customers, and they are never impacted for any failure. Because sometimes you have applications running with Elasticsearch. You do garbage collection, and sometimes it slows down a little bit. So you need to, it's hard to account with all these variables. So you need to have something to make everything be more resilient. And that's how we trust NGINX. So like, and talking about like talk, we have an average 1.2 million calls per week with an SLA almost 100%. We have less than 0.5% of dropped calls. And usually these dropped calls are not related to the infrastructure, are related to, or the guy drops the phone before even the request being made, but this still counts with us as a dropped call because we want to go and analyze and understand why, no matter what. Even if it's to say like, okay, there is nothing we can do because he turned off the phone before like even reaching us. So we need to analyze all of that. So platform as a service. So the technology of choice for Zendesk, for our platform as a service, we are using Kubernetes to do that. And the vision we have is that every single customer every single internal customer, like developers, we see operations, we see them as an internal customer because we need to give them SLAs. We need to guarantee the stability of the service. So they are our most precious customers internally, and we want them to be able to do self-service. So we don't want to be like a blocker, a wall that they can trespass when they need to deploy something. They need to be able to go and in 5 minutes they can have their application deployed or to staging or production or where they need. So that's why we are moving towards all of this automation with service discovery, automatic failover with using prepared queries, Kubernetes. So this is what will make this be true for us. And and especially because we are growing, it's when you are this is sometimes I have some fights over this, but in my opinion, microservices is way more to solve performance and people problems, performance as development performance, and people relationship problems than it is to solve technical problems. Actually, it's a huge technical problem, microservices, because every single request that before was internal to your monolithic application, now you have 3 hops of network in the middle of it. And so it's really hard to do that. But it's really hard to have like a team of 1,000 people taking care of 10,000 lines of code or more. It's pretty much impossible. So that's why like microservices, like it feels like it's a pain that we need to feel if we want to grow, if we want to give ownership of the pieces of the infrastructure to the teams, if we want to move fast, and if you want the development teams to be able to get in the morning in a meeting room, take the decision, in the end of the day they have the solution implemented. You'll never be able to do that with a monolithic software. So in my opinion, this is the biggest win that you can have. It's not technical, really, like, oh, it's not benefiting performance. No, it's not about that. So let's talk a little bit more about what we expect to solve in your near future. So as I was talking, self-service applications, but we are relying even more on service discovery to do that. Because automation, you do a change and then automation runs. If you rely this on service discovery, a change makes your automation run. It's a different, so we want it to react to anything that is changed and move forward. And NGINX API also can help us a lot with that. And we have things like, for example, rely on console template to create NGINX configuration, because service discovery lets you populate the upstream, but how you populate all the rest? That's why we use console template. It's exactly to be able to push the whole NGINX configuration, not just the upstreams, out and get this as fast as possible. Another service that is really important to Zendesk is search service. And we have a lot of questions like how we roll out new versions of Elasticsearch, how we do like failback if some requests fail on the new version. So how we warm up a cluster, because we want to do a failover. I can't just put in an empty cluster because we need to have the caches, like all the things in memory, how I reduce timeouts in garbage collection, and NGINX can help us with all of that. So for example, like if we want to roll out, like I want 10% of my customers going to the new Elasticsearch and all the rest to my old one, you can use split clients to do that. It's really powerful. And then you have your upstreams. And one thing that is really nice that we usually do is you put your new service, but you also keep your old service as a backup in your new definition. So why we do that? If your new cluster fail, you have an automatic backup that will fail over and go in place without you needing to do anything. But this only works if all the nodes go down. So what if I want to do this request-based? So if you want to do this request-based, you can abuse like error pages and the proxy intercept errors. What you can do is things like, I want, for example, 404, 500, 502, 503 errors to be redirected to the named location called fallback, that this will send to my old Elasticsearch cluster. So you can do this, every single request that fail, I say like, go to my other Elasticsearch and try again and see if it works. So like, NGINX is really powerful and you just need to like use their features, and you can achieve a lot with not a lot of, without using Lua in NGINX script or just by configuring NGINX. Now we have some nice things. So how we warm up new clusters. So this will work thanks to the new mirror, that new feature that was released, because this will copy every single request you have to your backend to another group that you want, and with that you can duplicate the requests and warm up your cluster before failing over. This way you can guarantee that you have everything cached in memory and everything that you need. So for garbage collection, it's pretty much what I was talking, like we use console. We keep the connections opened with Elasticsearch. We have a pool of keep alive connections. And what we have is, we instruct in NGINX to, in case of error, timeout, all of these sort of things, I wanted to use another Elasticsearch node that he knows. So if I tried something for some reason it's slow and I time out, what will happen that in NGINX you hold this request and retrying another Elasticsearch backend. Because this happens sometimes, like Java VM does garbage collection and some other things that you need to account over that. And I have some things that we've been working. We've been testing the new version, the release 13, and we got a lot of new nice features. But I suffer of like one thing that I call, it's a grep eye syndrome. It's the DevOps version of tunnel vision. When you see something that you like, you don't see all the rest around. It's what happened with me. So what we can use, for example, the API. We can use the API to enrich our service discovery. We can use, for example, when you create any HTTP zone on NGINX, it automatically adds two tags on my service. Or if I have service like NGINX that has cache and the other one without cache, I can add tags to that. And then what happens is that your application, they can choose. Oops. I'm spoiling all the fun already. So you can choose, for example, your application. So if I want to talk with this backend cached, you can just use calling cached proxy and the query that you want. Or if I don't want cached, I can use just proxy. So you can use the API to enrich your service discovery and give you even more control and make things even more dynamic to let you troubleshoot things and to be able to grow faster. But you guys saw the next slide, but I will show now officially. Because if we have key value store, that was one of the new features, and we also have mirror, what is blocking us for having a replicated key value store? Because basically what we can do is, all right, so I have my location replicated where I have my APIs enabled to have the key value here, and I'm mirroring that to an internal endpoint. And basically what I'm doing is that any request that is a write operation like a put, a delete, or a patch, this will be forwarded to my slave, and pretty much effectively I have a replication. It's just that the request was mirrored when it's a write to my backend. But one thing to pay attention is to this header here. And you understand why I'm setting this X replication source master here. So how, but that thing, I can't use the slave for much. The application needs to know if it's a read and write and send to different things. But we can use something similar to what OpenLDAP have that's called referral updates. So basically how this works. A request comes in to the slave, is a write. So it's a write and it's not from the master. That's why we have this header here. What I do, I return a 307 and send this same request to the master. So pretty much, if your client respects HTTP protocol, when you try to write to a slave, you receive a 307, you go to the master, write, and then the master you send back and write with the replication source master header that will skip this and let it write to the cluster. So then you can scale this out as much as you need. And I will give like some food for thought for you because this is way more complex, but just to show how powerful it is. Because if we can do that, what blocks us to leverage split clients and have sharding for key values? Because I can do split clients based on the key that we are using, and then I can say I want 25% of my keys in each one of these groups, and then this is replicated. So this creates like just by using normal NGINX configuration, no Lua, no NGINX script, nothing, you can still create really powerful solutions. But this is not as simple as using an out-of-the-box solution, obviously. But it gives you control of how you want the replication, where I want my keys to go. You can fine-tune as for your needs everything. So I will leave this as a food for thought for all of you, because like I started to write and I felt it was too much for a slide. But what I will do is, if you want a deeper dive in any of the things that was discussed here, I will start a series of posts on my blog talking about everything that I discussed, like how we are using the service discovery, the key value store replication, the sharded, and then in posts you'll be easier to go through all this more like detailed information than during 40 minutes presentation. So if any of you have any questions. All right, no questions. So thank you very much for your time. I really appreciate it. And see you guys. Thank you.